Hi, how are you guys? Welcome back to our Calculus 2 classes. Today, I want you to master the shell method. I promise if you watch the whole video and the next following videos and the previous videos, you will see how I'm going to make it easy for you. I'm going to use more rules, just follow the rules and try to copy these rules in index card, and I promise you will be able to solve any problem you want. Sorry guys. As I promise you to be able to solve any problem using shell method after we finish this method. At the end the last class, I'm going to make comparison between disk and shell method. Just wait for this video. Don't forget to subscribe and like to receive all our videos. If you have any question, this is my Calculus 2 application integration volume using cylindrical shells, and this is my phone to text me, and this is my email to send me an email. Always just back to the first minute of the video, you will see that. And don't forget to tell your friend we have SIT classes start soon, June 25. Like and subscribe. It's up to you. Let us go to our class and see what we have today. Look, surprise. 1, 2, 3. I'm gonna give you a nice surprise. Okay, what's my surprise? This is our class, application of integration, volume of a solid of revolution, cylindrical shells. And this is what we did. We set this a curve here, the green curve. We took a small shell, we rotate it about y-axis. We're gonna stick to the y-axis. I'm gonna back to the x-axis in a few minutes. Now look what I did for you. I make for you a table. Look to this table 1 second. Let me just explain it. Here we still rotating about the y-axis. Y-axis mean x equals 0. I put it there. Y-axis mean x equals 0. Right? I explained this before. Okay. This axis of revolution, which is the y-axis, and the limit of integration is a and b. Equation of axis of revolution, it's x equals 0. Since he's telling me y-axis, it's easy and simple, x equals 0. A rule for the radius of revolution, r equal x. Example 2 of 3, and my axis of revolution, then r equal x. Now if he change the axis of revolution from x equals 0 to any other number, x equals c, I have to compare it to the limit of the integration a and b. I have two cases. Either this guy less than a and less than b or equal to a, then my axis from x minus c. Example, look, 2 and 3, and negative 2 less than 2, which is a, and less than 3, then the rule x minus c. X minus negative 2, which is x plus q. X equals c, a and b. Now look here, if c now greater than b, the highest value which is b, and the greater than a, then r equals c minus x. Example, limit of integration 2 and 3, x equal 5, 5 is greater than 10 and 3, both of them. Then my 5 minus x. This is, if you follow this table, you'll be able to solve any problem using cylindrical shells. Let me just show you one example. I did this yesterday. Now, today, after I finish this example, I will go to the other part of revolution. Look here. We have two functions. I need the volume of the revolutions. I need the volume of revolution for the area between x squared minus 5x plus 6 and y equals 0, which is x-axis, right? Where I need it. Okay, y equals 0, which is x-axis. I'm going to change this, y equals 0. Okay, x squared minus 5x. Let me graph it, just 1 second. Okay. For you, I have the graph calculator here. Okay. X squared minus 5x plus 6 x squared. Let me just take this one line. I'm going to change this line. A small eraser. I'm going to change my function. X squared negative x squared plus 5x and y 0. Okay. Now I need to find here, before I start my problem, I need to find here on this side and this side the intersection point between these two functions, which is negative x squared plus 5x equal to 0. Take x as a GCF, right? Negative x plus 5, and this equal to 0. Then either x equal to 0, or in red, x equal to 5. Okay. Good. Then I have to. Let me graph the function. I'm going to graph it to show you the area I need to revolve. I'm going to show you the area I need to revolve. Okay, I'm going to take this line, make a nice line. Here. And I'm going to graph my function here. Zero and 5, right? Now the vertex negative b over 2a, right? The vertex of this guy negative b over 2a, which is in the side here, I'm going to erase it, negative b over 2a, negative 5 over 2 times negative 1. The vertex, if you remember that from algebra 2 and calculus, 2.5, right? This 2 and this 2.5, and if you plug 2.5 in the function, 2.5 squared plus negative 2.5 squared plus 12.5, 6.25. 6.25. 6.25. I'm taking my time. As long as you understand one problem, you will be able to understand any other problem. 2.5. 2.5 is almost here. Okay. And 6.246, 6 point here. Okay. Here. And the 2y intercept 0 and 5. This 2, this 4, and this 5. Good. And this is 0. Then you connect these points. Okay. And this, the area we want to revolve. Yani practice some algebra. Okay. This is the area we want to revolve. He wants to revolve it first. He wants to revolve it first about that area. We have 0 to 5, right? This 0, just give me 0 to where? 0 to 5. He wants to revolve it first about y-axis. Y-axis, my radius is x. My radius is x, and the formula, and I wish everyone remember it from the last time, but I'm gonna write it. V equal 2 pi, right? From my limit of integration 0 to 5, right? And the radius of revolution is x, f of what? X dx. Oh, that's it, period. Volume equal 2 pi 0 to 5 x time my function is what? Negative x squared plus 5 dx. dx. And I'm positive all of you can do this integration. Is the integration 2 pi, right? And integration from 0 to 5, this equal negative x cubed plus 5x squared dx, which is, I'm going to leave the last step for you guys, okay? To just more practice, negative x over 4 plus 5x cubed over 3 from 0 to 5. Okay, you can finish this problem. Okay, done. You can finish this guy by plugging the 5 and the 0, right? If you want me to plug it, just send me a text. I'm gonna come back and give you the answer. Now let us go to this guy about x equal negative 2. My limit of integration is what? Look here, I'm gonna start writing my volume. Volume equal 2 pi from 0 to the 5. Now, this guy, negative 2, is less than 0 and less than 5. Oh, which rule we need to use? Less than 0, this guy. Then x minus what? C. You see this? That 5, the negative, right? My x equal negative 2, right? And my a and b here, my a and b in this example, 0 and what? 5 and negative 2 less. Then x minus what? Negative 2, then x plus 2. Wow. You see how it's easy? You see how it's easy? Okay, let me just take this, keep the table clean for you. Then x minus negative 2, x minus negative 2 time negative x squared plus 5x right? dx. Let me just make it smaller. Negative x squared plus 5x and dx. Okay. Now just finish it. 2 pi from 0 to the 5 x plus 2 negative x squared plus 5x I need to be organized. I like to be organized. I don't want to be sloppy. Okay. 0 to 5 x plus 2 negative x squared plus 5x dx. Okay, then 2 pi 0 to 5, just multiply x negative x cubed, right, plus 5x squared minus 2x squared plus 10x dx equal 2 pi 0 to 5 negative x cubed plus 3x squared from these two plus 10x dx. Now equal 2 pi negative x4 over 4 3x cubed over 3 10x squared over 2. You can simplify this, I'm positive, you know that. This comes 5, and from 0 to 5. And I'm going to leave this also for you. What you do, just 5, this 5. I'm going to do this quickly. One of them, that's a gift. Negative 5 to the 4, negative 625 over 4 plus this 3 cancel 125 plus 25 minus 0. Minus what? Why 0? Because everything is 0. Then you add all these and you're done. Okay, I'm gonna finish it. Somebody's telling me finish it. I don't know who. This 150, these two 150 over 4, 600, right? 150 times 4, 600, right? 5, 25, 625 over 4, and this 150 times 4, 600, and this becomes negative. Okay, here x, look to my multiplication, negative x cubed plus 5x squared minus 2x squared plus 10x, negative x cubed plus 3x squared, negative x4 over 5x squared, 5, this 125 again, this 125, this 125. Thank you. Thank you. Thank you, Robert. You're following me. 250, 1,000, 375. 3 what? 3, forgive me guys, over 4. 120 feet, 250, over 4, 1,000. If you add it, this is arithmetic. And this is arithmetic. 2, then 375 pi over 2. Okay. Now the last one about x equal 5. Look here, the last rule here, right? 5 is greater than b, my limit of integration 0 and 5, right? Look here, and I meant to use this number when I change it. This is 5 and this is 0, and my c is 5, and my c is what? 5. I meant to have the same number. You see, when we have the same number, we're going to apply the rule. What's my radius? 5 minus x. Lucky me, right? Good. Then my radius 5 minus x. Volume equal, okay, I'm going to use this one. Volume equal 2 pi from 0 to the 5. Now, what we have? The rule, 5 minus x, right? 5 minus x, and my function is negative x squared plus 5x dx. Okay. Just the same. Volume 2 pi multiplied from 0 to the 5, negative 5x squared plus 25x plus x cubed from this following minus 5x squared. Minus 5x squared dx. Just combine the like terms. V equal 2 pi from 0 to the 5, from 0 to the 5, okay, x cubed first, negative 10x squared, this is negative 10x squared from here and there, negative 10x squared plus 25x dx. He told me, okay, I'm gonna finish it and we're gonna evaluate it, Robert. Okay, volume equal 2 pi, and this is gonna be x4 over 4 minus 10x cubed over 3, 25x squared over 2 from 0 to 5. The 5, the same thing, 2 pi. You're gonna finish it by yourself, guys. I'm gonna start 5 to the 4 over 4, 10, 5 cubed over 3, 25, 5 squared over 2 minus. Good job? Okay. This is for what? I have some minutes. Okay. I'm gonna explain the table for the y, or okay, that's good for this one. Then guys, see you how we gonna revolve the graph of the function about y-axis, about what? X-axis, I mean. Thank you for having me. Don't forget to subscribe and like. Thank you, guys.